right, students, today I'm going to be helping you understand quadratic functions, lesson 19.1, and this is the explore portion of it. Just wanted to go over a few quick things. First of all, you'll notice the equation has now changed from linear to quadratic. In the world of linear functions, we had y equals mx plus b, or we could rewrite it as a function of f of x equals mx plus b. But you'll notice the one thing common between both of these was the powers were always to the power of 1. If you don't see a power, it's defaulted to the 1. Today you'll notice that we're using a newer equation, and it's right there. It is f of x equals ax squared plus bx plus c. And for the rest of the school year, we'll be primarily focused on this equation. This equation is called quadratic. The reason it's called quadratic is because it has the power of 2. The power of 2 being quadratic. Therefore, you now have 3 new letters we're working with. We're working with the letter A, the letter B, and the letter C. Now, here's what they represent. A is the coefficient of x squared. B is the coefficient of the variable x, and C is the constant because it has no variable around it. All right, first thing you'll notice that they're going to do is in part A, they're going to use a table to find the values. Now, if you look at the function we're working with, the function they're going to be working with primarily right now is f of x equals x squared. Again, function notation is anytime you plug in something for x, you plug it everywhere you see an x. So for the first one, you'll notice they plugged in -3. So here's what they did. They did f of x. I really shouldn't have done this. I should have plugged in the 3 right here. F of 3 equals 3 squared. And of course, 3 squared is 3 times 3, which is 9. That's where they got that 9 from. So what did they plug in to get 4 as an answer? Well, that's pretty simple. You're going to do, what did you square to get 4? Well, what you squared to get 4, let's draw a little line right here. So here's the question. If I have this, and I want to get 4 out as an answer, notice the numbers they're picking. -3, blank, -2, 0, 1, 2, 3. So the only thing that's missing right here is a -2. So let's check it. F of -2 equals -2 squared, which was -2 times -2. And that gave you +4. So that checks out. What do you think you're going to get if you do f of 1, -1, as a -1 squared? Looks like you'll get out 1. -1 times -1 is a +1. What do you think you're going to get when you plug in 2? Well, pretty much the same thing you got right here, because that would be a +2 times a +2 would be a +4. And lastly, if I did 3 times 3, I get 9 again. Notice the interesting little pattern. You went from 9 to 4 to 1 to 0 to 1 to 4 to 9. This is very interesting. And it's very interesting because it creates something that we can call a parabola. Now, in order for you to see the parabola, we're going to have to go to Desmos, and we're going to have to recreate this guy right here. Okay, so if we go to Desmos, we want to create this that starts here and runs through here and skips this many times. So for our x's, we're going to start at, oops, that's not what I wanted to do. For our x's, we wanted to start at -5 run through all of our x's all the way till we hit positive 5 with steps of 1 and no title. For our y's, you'll notice it's way down here and it goes to way up here. Okay, let's see how we're stepping. We're stepping by, it looks like ones again. So for our y's, if we go here and add one more, we're starting at -2, running through all the y's. And if I add 8, 9, 10, 11, 12, looks like I'll get, wait, 8, 9, 10. The 10, because it's also steps of 1. Now, you're going to need to write all your ordered pairs down. And all my ordered pairs were -3, 9, -2, 4, -1, 1, 0, 0, 1 to 1, 2 to 4, and 3 to 9. So now that you have everything written down, I'm going to go ahead and consider this part 1 of the video, and then I'll pick it up at part 2 of the video on how to use decimals to graph again. Bye.